All right, in today's lesson here, we're going to be looking at the integral of sine x ln x dx. So first thing you want to do here is I want to break this apart. It's hard to integrate the sine of ln of x. So I'm going to go ahead and let t equal the ln of x. And if t equals the ln of x, then dt is going to equal 1 over x dx. So therefore we know that dx will equal x dt, but I need to represent this in terms of t because that's what my substitution is doing here. So from here we have t equals the ln of x. I can transfer this to exponential form, so e to the t equals x, and therefore we have dx equals e to the t dt. So substituting that in, this becomes the integral of the sine of t, and I can replace the dx with e to the t dt. So now we want to go ahead and integrate the integral of sine of t, e to the t dt. And this will be an integration by parts question, so I'm going to go ahead and let u equal e to the t, and I'm going to let dv equal sine of t dt. Therefore, du is e to the t dt, and v in this case is negative cos of t. So this integral now becomes et, put the negative sign in front, cos of t, so that's uv minus the integral of v, which is this one, du, which is e to the t dt. So cleaning this up, this becomes negative e to the t cos of t plus the integral of e to the t cos of t dt. Doing integration by parts again, I'm going to go ahead and let u equal e to the t. And this time dv is going to be equal to the cos of t dt. So du will be e to the t dt, and v is sine of t. So doing integration by parts again, this becomes negative e to the t cos of t plus uv, which will be e to the t sine t, minus the integral of v, so I'll write that down, times du e to the t dt. Now you'll notice here that this right here, this expression right here, is exactly what we were starting off with. So we actually have equality here. So this is the integral of sine t et dt. And by doing this, you end up having the integral on both sides. I have integral of sine t dt, and you have the minus right here. So I can go ahead and bring these to one side, and I'm getting 2 integral of, I'll put the e to the t in first, so this will be et sine t dt is going to equal negative e to the t cos t plus e to the t sine t. Dividing this out, you get the integral of e to the t sine t dt is equal to 1/2 e to the t sine of t minus e to the t cos of t. T value here, we had let t equal the ln of x. When I substitute that in, that becomes 1/2 e to the ln of x, the sine of the ln of x, minus e to the ln of x, the cos of the ln of x. And this will simplify here. You end up getting 1/2. E to the ln of x is just x, sine ln x minus x cos ln of x. And that becomes our integral and our answer here. You'll notice a quick observation. If you substitute this in for t and make note of dt equaling 1 over x dx, and you substitute both of that into here, you'll end up getting your original integral, which was integral of sine of ln of x dx, and you'll see it is equal to 1/2 times x sine ln x minus x cos ln x. Thank you.